Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about definition of basic elements of block diagram representation. This is linear control systems, linear lecture series on linear control systems and lecture number 21. So our topics, definition of basic elements of block diagram representation. Then overview. What is overview? Basic elements of block diagram. Canonical form of closed loop control systems. Definition of basic elements of block diagram. What is block diagram? What is output response? What is summing points? And what is forward path? What is feedback path for a system? The takeoff point or pickoff point, or basic idea of takeoff point or pickoff point. Advantage of block diagram representation. Disadvantage of block diagram representation. This is our main target or overview. Then basic elements of block diagram. What is the basic element of block diagram? The basic elements of block diagrams are: number 1, blocks; number 2, summing points; number 3, takeoff point; number 4, arrows; and number 5, forward path; number 6, feedback path. So our basic elements of block diagrams are this. And then R of S is reference input. This is also called set point or excitation, and this reference input always positive, and this is the summing point, and this summing point symbol mainly circle, and with cross or without cross. This is the with cross. And E of S is called actuating signal or error signal. Output of actuating signals, input of the block. This is the block or planned gain G of S. This is also called systems or any physical systems. And the output or controlled output C of S. This is the controlled output C of S. This is also called effect of the systems, and R of S is called cause of the systems. And the feedback information for better efficiency or better output response, this is the feedback path, and H of S is called the feedback gain, and this is the feedback. B of S, primary feedback gain, and this feedback negative. This feedback negative feedback. This is the canonical form of a feedback control systems. And number 1, this is the block. This is the number 1. So blocks. This is the blocks and block gain G of S. Next, number 2, summing point. This is the summing point. Number 2, summing point. And next point, takeoff point. This point is called takeoff point. This is the takeoff point. This is the takeoff point. And next point, arrows. This is arrows. And forward path direction. This is the forward direction. And this is the feedback direction. So our forward, this is the forward direction, input to output, actually forward direction, and output to input, this is the feedback direction. This is the feedback path also. This is also called feedback path and forward path concept. So next, definition of basic elements of block diagram. What is the definition of basic elements of block diagrams? So first point, input. This is the very important. This is also called excitation or cause of the systems. This set point or reference input may be analog, digital, continuous, discrete, step, ramp, parabolic, sinusoidal, any type of input you can apply. And this is the block. And output, this is also called controlled output. a figure, this figure for a simple open loop block diagram. This is the open loop block diagram because no feedback information or no feedback, just input, block and output. Then suppose in control system language, input is called R of S, reference input is called R of S, and block gain or system gain or planned gain is called G of S. And C of S is also called the controlled output or effect of the systems. So this is the block diagram with gain. While R of S is called reference input or controlled variable. This is also called cause of the systems or excitation of the systems. And C of S is called the controlled output or control variable. This is also called effect of the systems. And G of S is called the forward path transfer function. And the shorthand symbolic representation of the cause and effect relationship between the input and output of a physical system is known as block diagram. So what is the block diagram? Definition of block diagram: the shorthand symbolic representation of the cause and effect relationship, because cause is called input and effect is the output. So input and output relationship, input and output of a physical system. This is the physical system. This system may be analog, digital, any type of mechanical, electrical, any type of systems is known as the block diagram. The definition of basic elements of the block diagram. Output. What is the output? Already discussed this block. This is the controlled output. This is the controlled output, and control output symbol always in control system, C of S. This is also called effect of the systems. And R of S reference input, C of S controlled output, G of S forward path transfer function. Then what is the definition of output? The multiplication of the input variable, that means R of S, multiplication of the input variable R of S and block diagram or block gain G of S is known as output or controlled output or controlled output. So multiplication of the input variable, this is the input variable, and the block gain G of S. So R of S into G of S is called the output of the systems or controlled output of the systems or effect of the system. So C of S equals to what? C of S equals to reference input R of S and block gain G of S or system gain or planned gain G of S. Definition of basic elements of the block diagram. First point, summing point. So what is the summing point? A summing point is a point in a system where two or more signals are added or subtracted algebraically. So this is the very important part in control systems. Summing point is a point in a system where two or more signals are added, two or more signals added or subtracted algebraically. Suppose R of S one signal, this is positive, and this is the summing point with cross. And for R of S, the output is equals to C of S. And C of S equals to what? In this case, R of S, because without loss, output C of S equals to R of S. Then another input, also this is positive input, and this input equals to B of S. So what is the output? These two signal RS plus B of S. So RS plus B of S. And another signals, again, this is the negative, and this signal in Y of S. So C of S equals to R of S plus B of S minus Y of S. So Figure A, this is the figure A, summing point symbol with cross. And another symbol, this is the summing point without cross. R of S, B of S, and negative sign A Y of S, and the same output C of S equivalent to R of S plus B of S minus Y of S. This is the summing point without cross. Then symbol. What is symbol? A circle with and without having cross inside. A circle with and without. This is the circle. A circle with cross. This is with cross, and this is the without cross. So a circle with and without having cross inside. This is the symbol of summing point. Then the plus, this is the plus or minus sign at every arrowhead indicates the signals is to be added or subtracted. So plus or minus indicates the signal is to be added or subtracted. This is added, and this is the YS subtracted. The addition and subtraction have the same dimension, and same units. This is the very important, because addition, this is the addition and subtraction have the same dimension and same unit. Suppose this is voltage, so BS also voltage, YS also voltage. If this is ampere current, so this is also current, this is also current, this is also current. So same units and same dimension. This is the very important section. Then definition of the basic elements of block diagram: arrows. Next point, arrows. What is the arrow? Each block diagram contains arrows which indicates the direction of the flow of unidirectional flows of signals. So each block diagram contains arrows which indicates the direction of the flow of unidirectional flow of arrows. Also, arrows identify the direction of information of signal flow, direction of the information of the signal flows, and forward path. Next definition, forward path. The direction of flow of signals from input to the output is known as the forward path. So this is the RS input, and G1 is first block gain, G2 is second block gain, G3 is third block gain, and a controlled output is C of S. So this is the forward path. Input, output, flow direction, input to output is known the forward path. Block diagram of the forward path. Definition of the forward path and feedback path for closed loop systems. So what is the closed loop? This is the R of S reference input, and this is the sum comparator or summing point, U of S actuating signal or error signal, G of S system gain or planned gain, and controlled output C of S. Then the feedback path or feedback gain, this is the feedback gain H of S, and this feedback, primary feedback gain B of S, and this is the negative feedback. So this is the forward path for closed loop systems. This is the forward path for closed loop systems. And this is the feedback path for closed loop system. So what is the forward path? The direction of the flow of signal, from output to input is known as feedback path. Output to input flow is known as for feedback path. Then what is the forward path? The direction of flow of signal from input to output is known as forward path. So input to output direction is called, this is the forward path. This is the forward path. Then definition of the basic elements of the block diagram, the takeoff point. What is the takeoff point? The point at which the output signal or response of any block can be applied to two or more points is known as takeoff point or pickoff point. Takeoff point or pickoff point. Suppose this is the X of S input signals, and this signal direction is forward, and another signal, suppose this is XS and second XS and again third X of S. So this point is called takeoff point. This point is called takeoff point. So what is the definition? Takeoff point or pickoff point is a point. So takeoff point or pickoff point is a point from which the same input signal can be passed. This is the X of S input signal. Same input signal can be passed through more than one branch. More than one branch. In this case, three branches. In this case, three branches. So this is the takeoff point or pickoff point. Another definition, takeoff point can apply the same input to one or more blocks of summing or summing point. Suppose this is the X of S. Again, this is the direction of the signal, and first block G1S or planned gain G1S and the output X1S, and second block G2S and output X2S, third block G3S and the output X3S. So takeoff point can apply the same input. This is the input for G1, G2 and G3, one or more blocks or summing point, input to one or more blocks or summing points. So this is the basic idea of takeoff point. Then procedure for reduction of the block diagram. What is the procedure of the block diagram reduction? First rule. Rule number 1, reduce or simplify the blocks connected in cascade or series. Second point, reduce or simplify the blocks connected in parallel path. Rules number 3, reduce or simplify the blocks connected in feedback or parallel loop. Rules number 4, if a block diagram consists of many feedback loops, then find the innermost feedback loop. Rules number 5, if there is difficulty with takeoff point while simplifying, shift it towards right. And rules number 6, if the innermost feedback loop contains any takeoff point or summing point and there is difficulty with summing point while simplifying, shift it towards left. And rules number 7, obtain the transfer function of overall system, that means CS by R of S, controlled output divided by control input. All initial condition is called the transfer function. And repeat the above steps till you get the simplified from, that is single block. That is single block. This is the very important. This is the very important point, rules number 8. So what is the advantage and disadvantage of the block diagram representation? Advantage of the block diagram representation. First point, for a complicated system, the construct of block diagram is very straightforward. Second point, function of all the individual elements can be visualized. In block diagram reduction, individual and overall performance can be studied. By using block diagram reduction technique, the overall transfer function can be calculated easily. Overall transfer function can be calculated easily. And disadvantage of the block diagram representation. In this technique, no information about the physical construction. Second point, generally source of energy is not exposed in the block diagram system. For a specified scheme, the block diagram technique is not unique. This is the very third point, very important. For a specified scheme, the block diagram technique is not unique. So thank you.